Whoa. Shit, why is this thing turning off? Oh shit. Sound. Good afternoon, everyone. I just had a technical issue. One of my computers crashed, but I am online with you still. You guys can see things. I have to open up a chat to be able to see what you see. Give me an instant. Marlene sent me some questions, so I want to tackle those questions first. Do you see her first question? I can't believe this just crashes. It keeps crashing. I don't have a second computer. Ugh. So I'm going to have to open it here. Sorry, so what I plan to do is to put timestamps on the video so that you can just click to the things you want to see. You don't have to see all this troubleshooting. You have to watch the video to see me. Okay, it's showing. Well, I don't have my face on right now. I just have this question that Marlene sent. Let me open up the chat. Okay, so I see you. So make sure you subscribe, because I think if you subscribe, I can maybe send you notifications or something. I guess I can do that in Moodle as well. But anyways, so I only have 4 people. So I guess people plan to come late or they plan to watch the video. So I'll make this as useful as possible. This question was taken from among the quizzes online, I believe. So, length of commercials airing on a particular network follows a normal distribution with mean 31.8 seconds. So we say X, right? Follows a normal distribution with a mean of 31.8, and it doesn't tell you the standard deviations, right? But it does give you information that 6.68% of commercials are less than 27.3 seconds in length. What is the standard deviation? That's the question. That's what you want to find out. So, you're given information about that the probability that the curve, the area under the curve, is smaller than 27.3 is equal to, is equal to 0.0668. So that's a backward, that's information that's given to you in a backwards way, right? So what you want to do is interpret that. So the area to the left of 27.3 on this particular distribution, that's normal with a certain mean and a certain standard deviation. So what we have to do is work backwards. We're going to take the we're going to take the approach of the 2 steps. So in the first step, we find out that in normal distributions, in general, well, we know from the notes and my examples that in the normal distribution, the way that the z-scores, a standard normal distribution, the way the z-scores are spread out correspond to other standard normal distributions, all relative to the mean, right? So if I plot this on my z, okay, this is the z, then we know the area to the left of x, we know the area to the left of x is, on the x drawing is 27.3, but I'm going to refer to where is that in relative to the mean of x. So to draw this, I use this value here to help me identify where I am relative to the mean. So I take this area here, let's move this. Things are not working. Oh, I want to erase that, but okay. So that area is 0.0668. So what I do, since the tables that you're given are given to you identifying the percentiles, so inside the table you're going to find that number, and that's on the from that value, go to the outer edges and tell me what the z-score is. In other words, how many standard deviations are you below the mean? So find C. So what would that be, everyone who's watching? Try that. Check out the table. I'll wait for you. Are you finding it? I'm waiting for you to tell me on the what is the z for 6.68% on the left. Okay, so you looked it up. Marlene gets negative 1.5. Anybody else? Anyone else confirm that? I don't know my video. I have to fix this. There we go. I'm waiting for someone to tell me what the z is. Marlene told me negative 1.5. Do you agree? Uh-oh, we have a different answer. Okay, let's see. Okay, I just want, hi Kay, I just want the z-score right now. Negative 1.58, or is it negative 2.48? Someone break the tie. I mean, break the, I don't know what to call it. Someone tell me. Hi, Kay. Okay, you got it now. All right, so negative 1.5. So now with a negative 1.5, that's going to give me the how many standard deviations I am away from the mean. So what we do is then we do the second step where we translate that. Okay, the second step is x equals z standard deviations from the mean. Now, what do we have? We have information on x. What's x? X is this value here. So that's the little x, right? So this expression shows you the relationship between x and z is just a transformation from z telling you how many standard deviations from the mean to actually the units of the variable that we're interested in. So we're taking the standard deviations from the mean that are negative 1.5, multiplying by the mean, multiplying by the standard deviation and adding the mean, 31. I think I'm going to run out of space. Hold on. Let's do that over here a little bit. Oh no, I ran out of space, didn't I? I got to get used to this, guys. There we go. So this is what I'm working with. And then I'm going to do x, which is 2.73, equals z, which is negative 1.5 standard deviations from the mean, which I also have of 31.8. And then I solve. Now you can solve for a sigma. Let me make that clearer what that is. That's a sigma there. We're going to solve for sigma. Sigma equals what? Okay, this is really messy. I need to get a proper stylus. I haven't found one in my house. Okay, so solve that and tell me what you get. So you're solving 2.73 minus 31.8 divided by negative 1.5 will be sigma. Is that what you get, Heike? Hello? Anyone calculate that? It's getting smaller and smaller. Marlene, you're going to calculate sigma, so this is algebra here, okay? So you're going to calculate, looking for this item, this is the standard deviation. So we need to isolate, so 2.73 from here, minus, because this, you have to subtract 31.8 from each side, so you subtract it here and you subtract it here. And then with that amount, divide that by negative 1.5 to find sigma. How is that? Okay. I have some delay, so I'm talking after you've posted, probably. So the standard deviation will be the solution of this. You can tell me if that was the correct answer or not on the quiz. Oops. Oops. Okay, Marlene. Do we have confirmation? So I'll just plug that in. All right, you guys are getting the right answer? Very good. Let me check, because I can't trust you. So Marlene, is that the answer that's showing on the quiz? Is it a negative or positive? Be careful with the algebra. Is it a negative or positive? Very good. It's positive. That's correct. Okay. You see that's positive. So this is going to be 19.38 positive. So is that the right answer? Is that the answer in the quizzes online is the question. You guys can double check. Okay, so it's a backwards problem, and that's pretty much it. And how did I know to do that? What were the keywords to do that? The keyword to solving this problem was them telling me that they gave me information on the percentage, and I had to find the value corresponding. Okay? So I needed to get there, I had to use the standard normal distribution and then a transformation to get me to the original variable. Very good. So let me see if I could get back, if I can make this bigger. You can see the original problem. So the original problem here they explain lengths of commercial airlines on a particular network follow normal distribution if. So this is what tips me that it's going to be a backward problem. They gave me a percentage. They tell me about the length that it's going to be less than. So this is different. This is I refer to this as a backward problem with a twist, because rather than asking you for the position or the value that corresponds to this percentage, in other words, rather than asking you for the percentile where variable takes on a value above 6.68% of other observations, rather than that be the question that they're asking you for the standard deviation instead. So you have to solve for that instead. So you're not looking for the value, you're not looking for the score. In other words, you're looking for the standard deviation. Okay, so how's that? Let's try the next problem. I've loaded it. I'll save that. I don't know. Maybe you might want that at a later date. I'm not sure. So let's see this one. Okay. Do heavier cars use more gasoline? To answer this question, a researcher randomly selected 15 cars. He collected data about the weight and the mileage for each car. From a scatter plot made with the data, it looked like a linear model was appropriate. The equation of the least squares regression line was this one. The percentage of variation in mileage that is accounted for by the linear relationship between mileage and weight is approximately this. So, what they've given you is the regression line. They've given you the regression line. They've given you this. We talked about this yesterday. The percentage of variation is r squared. That's how you interpret it. Okay? This is r squared. And all they want is the correlation coefficient. Now you got to just check that they're still talking about the same thing between weight and mileage of the car. So remember this linear equation is the weight versus mileage. Get data from the weight and the mileage of the car. It's not exactly clear, is it? The equation sorry, I'm just reading them now because I just got to see them now. Mileage and weight. So, okay, so what I'm being cautious about is making sure which variable is x and which is y. It actually doesn't matter with the correlation coefficient. You think about the formula for the correlation coefficient, x and y are treated the same, right? So r is the correlation coefficient. Depending which variation of the formula you choose, right? It looks like x and y are treated the same. Both of them are subtracted by their, oh, I forgot the bars, by their mean, no, I did it backwards. This x xi minus x bar. Yeah. I don't think I can go back to do This is why it takes forever to make these videos. Oh, I lost it completely. Ugh. Anyway, so x and y are treated the same. That's the point in formula. If you look back, so it doesn't matter which is which. So what really does matter, it matters which variable is x and which one is y when you're talking about the line, okay? So anyway, the point is the slope is negative. The slope and the r have the same sign. They have to have the same sign. Okay, they have to have the same sign. So here you're told about the slope, because you know the slope is the value that comes right before the x, okay? Remember the formula for the line. If you don't, watch the video, review that, watch it as many times as you have to. Oh, you're asking me a question about the other question. Heike, I have to go back and look at that. All right, so all you do, this is the same as the quiz that we did. So r squared is equal to 0.44. That means r is equal to the square root of 0.44, but don't forget the sign. That's a negative. Why is it a negative? Because the slope and the r have the same sign. The r is the measure of direction and strength of the linear relationship between two quantitative variables. So they have to have the same direction, in this case negative. So that's how you solve that, and take the square root. And what's the answer there? Don't forget the negative. So I get 0.66. How's that? I have to go back and look at the other problem now. Maybe I made a mistake with my decimals. Let's see. So any questions about this one? I don't think so, right? So this is negative. All right. So I'm going to save that, I guess. Yes, so then I can go back. This is question 2. Now what the heck did I do in question 1? Let's see. Oh, it's a whole video. Well, am I going to play it? Let's see what I did. 2.7, 27.3. Oops, see, I put the decimal in the wrong place. All right. You guys repeat the question with 27.3 and see if you get the right answer, because I'm having trouble with the stylus and I put the decimal in the wrong place because I was struggling with my penmanship. Okay, so I leave it to you to solve this, and it's in the quiz online, so you'll find out what the right answer is from there, okay? Marlene gets... Yes, that's right. That's for the problem we were doing. All right. So second problem, negative 0.66. Yeah, you can put 3 decimals or 4 decimals. At this point, whenever, when I deal with the problems in general, I keep 2 more decimals than the numbers I've been given. So I probably would keep just 2 more here. I would put 3 on. That would be that's my approach. Okay, so I'm gonna Okay, so that's that. Now let's see if I get another problem. Sorry that I shouldn't apologize, I guess, but if this is confusing you, you can go back and watch it or ask me a question. Please send the questions early on, so I can maybe prepare them and not goof up. Okay. I'm just preparing the next one. Well, I think we did the next one, quiz 3.33. We did that yesterday. Should I really do it again? Yeah. Okay, so the third one that she asked me for, sorry, just looking to make sure I have answered all the questions. Okay. So I'm scared to get out of here for fear that it's not going to work. So I'm back. So, do you have other questions? Yes, go back in the videos, Marlene, please, and just look at that one. Well, it's just the video before. I'll timestamp things in the video so you know where to go for the questions, okay? So I'll prepare that after we get off. What other things do you want me to talk about? Any other problems I can pull up? Do you see me? Anybody see me? I only have 8 of you and there's 30 in the class, and I do hope people take advantage of the opportunity to contact me. There we go. Flashing back. Okay. I could do exam questions. Do you want me to talk about any particular topic, or do you want me to do exam problems? I can load some exam problems. What do you think? Yes, that's right. Jian, the R was negative. I solved that yesterday. Like I say, I'll put the tags or the timestamp so you can see those solutions. But yes, the slope was negative for the quiz. That's right. So should I get some tests or something? I have to prepare that if I'm going to do that. Okay, let's do some exam problems. Let me save this. See, I have to prepare all these documents in a folder, so that's why you have to ask me the questions in advance. so let's get out of here. And okay, if I crash, just hang in there, I'll come back. Okay, so these are questions among the exams that I prepared for you on Moodle. Let's see, let's just do two problems. And go back to OBS. Okay. All right. I'm gonna have issues with this. Okay, how do I put this in the thing? Okay. Oh, it has to load the whole thing first. And let's just do some problems. So I think so this is in, I'm not sure which one exactly, but this is among the questions. So let's see if you can do this one. It's like crooked. So read that problem and give me your answer. Oh, Chloe, I just saw your comment. I guess I can pull up that problem. So you should be trying this problem. Okay, I see some people made a choice. Okay, let me talk about them. You can pause the video if you don't want to know yet. So film ratings exist to inform parents about the content of movies so they can decide which films are appropriate for their children to see and at what ages. Examples of film ratings include general, parental guidance, restricted, and NC-17. So these are, you guys are saying C and B, C and B. Okay, so you realize this is categorical. Very good. So, I mean, they're all options are categorical. So it's categorical, but the question is ordinal or nominal. What are we interested in? What is the variable? Film rating. Film rating is on a scale of general to restricted. Okay. Fully restricted is the last one. So already by talking about that kind of a scale, that general is the most general. It's the most generic. Anybody can go, right? To the most restrictive, that no one under 17 can go. So this is an ordinal scale. So we have between A, D, and E. And Marlene said D, so let's keep going. Anyway, so far it's the first one is categorical and ordinal because the order matters. Let's look at students of the martial art karate wear different colored belts depending on their skill level. There are 9 belt colors in total. Students start with a white belt, beginner, and work their way up to a black belt. What does this sound like? Again, all the options say categorical, so it's categorical, but again, is it ordinal or nominal? Is one better than the other, and is it on a scale? So, in fact, it is ordinal. So now we're down to A and E as the options, okay? So the color belts depend on the skill level, and you work your way up to the darkest, the black, from white to black. We had an exercise similar in class, where the darker color of hair indicated that was a variable, the darker color, the hair color, or the darkness of hair, I think that's how I termed it. That's how we knew it was an ordinal variable. Same thing here. Okay, finally, when making an international phone call, you must dial the country code followed by a person's phone number. For example, the country code for France is 33. The country code for, I guess I can use this to, the country code for Australia is 61, and the country code for Mexico is 52. So now, by process of elimination, we're down to A or E. Which one is it? I'm just waiting. Yes, it's A. It's A because your number after your country code, I mean, there's no, France is not better than Mexico, is not better than Australia. That's not how those numbers were determined, or there's no relationship that orders those numbers. They are rather meaningless, okay? The only thing it means is France was assigned 33 and Mexico 52 and Australia 61. But 61 is no better comparative to 33 or 52. Okay, so the answer is A. A is the answer. A is the answer for that one. Okay, so you guys get it. So there was just a matter of reading through that. So that's an example of a Unit 1 type question. Let me keep going. I'm going to keep going. Okay, this is a one that tricks everybody for some reason. Why don't you try this one? We'd like to make a histogram with vertical bars of the number of vehicle thefts last year in all North America cities, with populations over 1 million people. The horizontal and vertical axis represent. So try and draw this for yourself and tell me what is the answer. This is 80% of students get this type of question wrong for some reason. Probably should pause the recording, but I don't know what's going to happen if I do that. Okay, so I have some, you guys are trying the problem. I should have music play. That's what I'll do. I'll put some music on. Okay. I want a few people out putting out their answers because you're going to see it's not so bad. It's not just you who doesn't get it. I am putting you on the spot, and that's just fine. It's better to be put on the spot now than during the test, right? That's my approach. That's why I put dozens of quiz exams up so that you don't have to be surprised. There you go, some music. For your listening pleasure. All right, so let me see if I can explain this. Okay, we'd like to make a histogram with vertical bars of the number of vehicle thefts last year. I'm going to pause this now. In all North America, with population over 1 million people, the horizontal and vertical axis. So usually, right, it's a histogram. A histogram has the counts on this axis. Oops, that was terrible drawing. I really need to practice. So that is going to be the vertical axis. The vertical axis is going to have the count, the number or percentage, right, of what, of vehicles. Vehicle theft, sorry, let's say theft. Oh my goodness. Number of thefts. And then okay, sorry. I'm gonna put number there. We're counting. See? Okay, we're going to put the count in here. So that's going to be like the frequency on this axis. Let's write that word. It makes more sense. So this is frequency of what? The frequency of thefts and on this axis, on the horizontal axis, what you're going to be doing is on this axis, you're going to include the thefts in ranges of values, right? It's a way to organize the data. So you're going to put like numbers together. So this is going to be the count, and this is going to be the theft. So it's going to be like, if you remember our drawing, right? We're going to say thefts between thefts last year in all cities. Okay, so out of all the North American cities, they took a record of the number of thefts, and the cities with the cities were counted with thefts between, let's say, 0 and I don't know, 1,000. Okay, so let me see. Let me. This is terrible. So you're going to. That's not 0. This is 0 here. So 0, and then let's say 10 and 20. Let's just do it like this. Okay. So how many cities had 10 to 20 thefts? How many cities had 0 thefts? 0 to 10 thefts. How many cities had 20 to 30 thefts, etc. Okay, so that is going to be what it's going to look like. So the answer is, now you got to read this carefully, the question, horizontal and vertical. So the horizontal is this one, and the vertical is this one. Okay, so you can narrow down your answers by just looking the ones that, the vertical is always going to be frequency. How many cities had 0 to 10, how many had 10 to 20 in total, right? And so the answer is what? A. Okay. You want more? Give you another problem. So that's kind of a GDS type of problem. Let's do a regression type of problem because we spent some time on normal already today. Let's see if I can get a regression type problem. Am I going to be able to get out? I'm just getting a page at a time. So you're seeing what it takes to make these videos. So let's try. Okay. So regression one. Okay, let's try these. I have to reload. Oh no. So I gotta do it page by page. Well, I got 2 questions. That's insane. I want the next page. Oh, there's the pages. Okay, that's gonna be a lot of work. So, go through these, start doing these problems. This is your best approach because this is what you're gonna see. This is what you're gonna see next week. Okay, so what about these problems? Let's do 11 and 12, and then we're gonna go over a bit. Some of you have to go to class or you have other responsibilities. Go ahead and just check back. Like I said, I'll put the timestamps in so that you can quickly click through. So this is question 11 of that sample midterm. And these are, again, among the midterms that I provided you. Okay, so let's see. Consider the following sample measure. So consider the following sample measures of center, spread, and association. How many of these measures are resistant to the effect of outliers? Okay, what's your answer? So go one at a time and include or just exclude. So is mean resistant? No, mean is not resistant. Because the mean is not resistant, neither is the standard deviation resistant. So those are out. Range is resistant. So mean is out. Standard deviation is out. And because the mean and standard deviation make the correlation, that's out. So all that leaves is the range. So the answer has to be B. Okay. And last, so I'm going to do this one and then I'm going to get going, but tomorrow what I'm going to teach is how to use the calculator to calculate the correlation coefficient. I showed you how to use the calculator to get the standard deviation, so review that, and at the beginning of tomorrow's session I will show you how to get the correlation coefficient and the regression line coefficients out of the calculator. Okay, and I'm going to demonstrate for the BA2 plus. I can do that streaming from my phone. If you have a different calculator that you want me to advise you on, please let me know in advance. Okay, so let's do number 12. Well, actually, why don't you try it? Try number 12, and then I'll check back. Okay, so I repeat this. It's like a mantra. I keep repeating in my videos and even in these sessions. I've said it a few times today. The correlation coefficient is a measure of the direction and strength of the linear relationship between two quantitative variables. All right, so let's see. If I go through these, does it cover what I just said? X and Y are both quantitative variables. Yes. Okay, for R to be meaningful. The relationship between X and Y is linear. Now that's not necessarily true. it doesn't have to be a line, but it can be, now see, now I'm going to be questioning what they wanted, but I'll explain it. So it's linear in the sense that it looks like, you know, you can see that. It's linear in the sense that I could fit a line that's closest to most of the points, and most people would agree with that, understanding what I'm trying to do. So we call that a linear relationship, even though it's not on a line, okay? If it was wrong, it would say x and y are, the variables x and y are perfectly linear, but it doesn't say that word, okay? So that's okay, so 2 is okay. 3, x is an explanatory variable and y is a response variable. Okay, so this is back to something I said today as well. I don't need to know, to understand R, I don't need to know which one is x and which one is y. Again, this is because the formula for R is so this formula here, it's very messy, but you guys can see it in your notes neatly. Whatever I do to x by transforming it or standardizing it, I do the same to y. So it's not necessary that that I know exactly whether x, the variable named x, is an explanatory variable, the variable named y is a response variable. Okay, that's not a condition that makes R meaningful. Okay, so R is calculated, x and y are treated the same, and that's why the answer is C. Okay, so any other questions for me right now? I changed the schedule in the Moodle page on our Moodle platform. I changed the schedule so you can see in the Moodle platform, you'll be able to see the latest or updated schedule. And otherwise, please communicate with me through there. Let me know the questions you want me to cover. Let me know what you really need only after you've seen all the videos, okay? So spend time. I'm only visiting with you 1 hour a day, so that's 5 hours a week during the work days. Again, I could stream on the weekend. Let me know if you want me to stream on the weekends. And I can just do questions like this and bring you, you know, you'll see that I'm repeating myself. That's what it really does feel like. I'm repeating myself. So tomorrow I'll do a review of how to use the calculator to calculate R and how to use the calculator to get the coefficients of the line, the least squares regression line, and I'll also look at, there was something else I wanted to show you. It just slipped my mind. But, there's some questions in NOR that are not in the notes or not in the videos that I want to use for a demonstration, so maybe I'll do those, okay? Let me know what you need. So, I don't know why I can't see you. Oh, I think I have to go like this and say goodbye. Did you guys leave yet? Some of you haven't left. I think it's coming back. It looks like it's flashing on and off. Anyway, I'll work out my difficulties. Jan really helped me yesterday. I'm very grateful. Foster. however you go by your name, local foster. So, well, I'll see you tomorrow at 5. I don't know why I can't get my image up, but take care.